A lorry loaded with explosive, driving inside one of the biggest holes in Europe, the ICI Tunstead quarry in Derbyshire, which produces a very important raw material, limestone. A special rig drills holes deep down under the limestone surface. Putting in another section, it's called a stem, so that the hole can go down deeper. The holes must penetrate to the bottom of the 21-metre quarry face, and then nearly 2 metres below that. Explosive for blasting will be put in the hole. In the meantime, it's covered over to stop material from falling into it. A line of holes is made, carefully placed a measured distance in from the quarry edge. The holes must now be filled with explosive. An igniter goes to the bottom. Then they pump in a slurry, a mixture of diesel oil and an oxidizing agent. Cable is now laid, so that the explosive inside the holes can be electrically detonated. The detonators are fixed in position. The special cable which goes down into the holes is itself an explosive. Now powdered rock from the drilling is shovelled in on top. The vehicles leave the scene. They will detonate the explosive from the shelter of a concrete igloo.
Okay, Nell, fire away.
Everyone must take shelter.
Starting the countdown now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
The explosion is staggered, with a fraction of a second between the detonations in one hole and the next. This reduces the noise and vibration caused by blasting. If we repeat in slow motion, you can see this. This particular blast brought down about 50,000 tons of limestone, which must now be removed for the first stage in its processing. The trucks hold 40 or 50 tons of rock. Each shovel load is about 15 tons. This limestone, a form of calcium carbonate, was made from the skeletons of billions of tiny sea creatures laid down at the bottom of ancient seas over 200 million years ago. Now it'll be converted into useful materials. First, the limestone rock has to be put through a crusher which will break up the bigger boulders. A gigantic steel pestle crushes the rock against the steel side of the crusher. The pestle's mounted on an 8-ton bearing. You can see the movement of the pestle, driven by a powerful electric motor. This goes on continuously, and the crushed limestone is carried away on conveyors. You can see that there are now no very large lumps, but there's still a range of sizes, from small fragments to bigger pieces. The material passes over a set of sieves which sort the different sizes. The larger pieces go to a second crusher, so that in the end it's all quite small and is fed into a series of hoppers by this machine. It runs continuously backwards and forwards, dropping the crushed rock into the hoppers beneath. You can see that there are no longer any big lumps. Jets of water wash away any clay, which would otherwise accumulate and eventually block the outlet from the bottom of the hopper. Underneath the hoppers, the material is thoroughly washed with water, which carries away small particles and fine dust from the surface of the pieces of rock. More sorting of the now washed limestone in other parts of this vast building. All this machinery has to be monitored and controlled, and there's a central control room where they can keep an eye on everything that's happening. From this building, different grades of limestone are conveyed to other parts of the plant. This will be used as road stone for road making. Remember that all the rock was washed. The washing water carries, as well as very fine material which we'll come back to later, sand, which can be separated out and sold. Some limestone leaves the quarry by rail to go to another ICI plant where it's used to make sodium carbonate, needed in making glass. But some of it is converted to another chemical here at Tunstead. If you heat calcium carbonate, it decomposes to produce calcium oxide, quicklime, and carbon dioxide gas. Here's calcium carbonate being decomposed in the laboratory. You have to heat it very strongly. The quicklime formed gives off a bright white light. This used to be used for stage lighting, the limelight. Now, if you decompose limestone like this, you can only do it in one batch at a time. Industrially, it can be done as a continuous process using a rotary kiln. Here's how it works. If you feed the raw material into a slowly revolving hollow cylinder, it gradually works its way to the bottom. Heat the limestone sufficiently in the rotating cylinder, and what comes out from the bottom will be quicklime, calcium oxide. This is only a small laboratory mock-up. At the quarry, the kiln is a huge, heavy steel cylinder, many meters long, putting a load of 80 tons on each of the 5 pairs of bearings which drive it. You could heat it like this from outside, but it wouldn't be very efficient. Why not blow a flame right up inside the kiln? This is precisely what they do. Natural gas and air are pumped in to produce a great roaring flame inside the huge rotating cylinder. You can see the material, quicklime, by the time it gets to this end, tumbling down the moving wall of the kiln. The carbon dioxide produced passes up the kiln and is cleaned to remove any fine particles of solid before it's released into the atmosphere. And the limestone goes in at this top end, of course. Here's the stack for the cleaned waste gases. The rotary kiln is a very impressive piece of engineering. This one produces about 140 tons of quicklime a day from 250 tons of limestone. About a third of the limestone quarried here is burnt, as they call it, to make quicklime. The design is such that practically all the calcium carbonate's been decomposed by the time it reaches this end of the kiln. Here's the hot quicklime spilling out from the end of the kiln. It's operated from a control room. The hot quicklime, calcium oxide, is air-cooled in this big cooler. Much of this quicklime is sold to steelworks for making steel by the basic oxygen steelmaking process. Back to the laboratory. Add some water, cautiously, to quicklime. There's a quite violent reaction. You must protect your eyes against splashes. This is what's happening. The quicklime, calcium oxide, reacts with water to produce slaked or hydrated lime, calcium hydroxide, and a great deal of heat is generated. They slake lime on a much bigger scale in this part of the plant at Tunstead Quarry. At the top of the building, fresh quicklime is weighed out in carefully controlled quantities. They need to know exactly how much quicklime is being introduced. There's a carefully controlled water supply, so that exactly the right amount of water is added to turn the quicklime into slaked lime. It's a continuous process, and the water goes in here, mixing with a thin stream of quicklime driven along by a screw. The quicklime water mixture is driven along through a series of cylinders, and when it gets to the bottom, all the quicklime has been turned into slaked lime, calcium hydroxide. There are several sets of these hydrators. By gradually mixing the quicklime with the water in this way, a smooth, controlled reaction is achieved. Here's the control room. The dry powdered calcium hydroxide, slaked lime, is loaded into road tankers for delivery either to other ICI plants or for sale to customers. About 40 to 50% of the quicklime made here is slaked, turned into calcium hydroxide, a mild alkali which is used when it's necessary to neutralize acidity, for example in water treatment, as you can see in another Chemistry in Action film. Back to the huge building where the crushed limestone is sorted. You'll remember that the pieces are washed, and the washing water carries off sand which is separated out. What's left is a slurry of very fine solid matter and water, and this is used to make that very useful material, cement. You also need bauxite, impure aluminium oxide, iron 3 oxide and sand. Here are the stockpiles. These are mixed in the right proportions and carried up to a huge wet mill where they're thoroughly mixed with the slurry carrying fine limestone dust from the washing process. Steel balls inside this big cylinder grind and thoroughly mix all the constituents. Heat is generated inside by friction, so the mill's sprayed with cold water. The mixture is heated in another giant rotary kiln, which produces cement clinker. This can then be ground to fine cement powder and sold. Cement manufacture uses up less than 1/10 of the limestone that's quarried at Tunstead, but it is an important product. By road and by rail, roadstone, and limestone for conversion into sodium carbonate for glass making, and into quicklime, slaked lime and cement leave the quarry day after day, month after month, year after year. When will all this limestone be used up? Well, there's a lot of it here. Despite the continuous quarrying and crushing and burning that goes on at Tunstead, the beds of those ancient seas left us enough limestone here to last until at least the year 2050. And that's a lot of limestone.